Okay, this is a very difficult Poisson distribution question. There's things you must always do with all distribution questions, and the good students do this every time, and that is write down what the distribution is. So this one is a very obvious distribution. It says it's a Poisson, but we don't know lambda. So we write x is distributed as a Poisson lambda. So important that you do that. Obviously, normally it's a harder thing than this. Now, the next thing, though, is an English sentence that's asking you to calculate something. The probability of exactly 2 errors is the same as the probability of less than 2 errors. And I capture that English sentence in really clearly written maths. And this is actually an equation. The probability that x equals 2 equals the probability that x is less than or equal to 1. Notice I changed less than 2 into less than or equal to 1. You must always do that because the calculator only deals with less than or equal to. So how do you solve equations in maths apps? Yes, solve n. So I'm going to go here and I'm going to type solve n. Now, what am I solving? Well, I want a Poisson x equals 2. So I'll go to options, statistics, distributions, Poisson, and PD means exactly 1, a particular 1, and CD means between 2 numbers. So PD is the one we want, Poisson PD, and it asks you to tell you how many you want, 2. Then you type a comma, which is just above the delete button, comma, and then it asks you what the mean is, but we don't know it. So I'm going to type x. So that is Poisson PD 2 comma x, and I want to say that's equal to less than or equal to 1. So I will go equals. So I have to move my equals. And now I want to type less than or equal to 1, Poisson CD. And I want to go between 0 and 1. And then I have to type the mean in, which is x. So that is Poisson equals Poisson, close the brackets for the solve n. And it's going to search through, basically looking for solutions. And it's found, now oddly, it's found 2.73. So does that make sense in this question? Lambda equals 2.73 is a sensible number, a number of mistakes per page. And the probability of 2 mistakes makes sense. So that is the correct answer. Notice there is, and you often get this, a very strange answer, 243. 243 mistakes on a page. It doesn't make any sense. And the reason why it's coming up with an answer is that it's, if you have 243 mistakes per page, what are the chances of getting exactly 2? It's virtually 0. And so is this one. So they're so close to 0, the calculator has mistaken them for being equal. So you have to apply a little bit of common sense. Okay, so that's it.